So guys, let's quickly look at the third chapter where we'll be focusing on our changing earth. When I say changing earth, we are actually talking about different features that are actually present on earth. You can look at mountains, plateaus, plains, deltas. You can see some rock structures coming up, some going down. There are certain civilizations which have been vanished. What are all the reasons for this? You might have heard of volcanoes, earthquakes. How does this happen? What is the reason for this? To understand some points, first we need to understand these, first let us take a container and you are heating it. Okay? Now when you have water, just add a piece of paper. When you boil it, we know that first these portions will be hot. And we usually observe the hot water rising. If you cannot observe the hot water rising, you can see this paper ball will be moving above. So there will be this movement. Again it will be floating. The meaning of this is hot water rises or hot air rises. I have given you this example. And cold sinks. Correct? So usually we see hot or warm rising and cold is coming down. This is actually a convectional process which we usually observe wherever heating takes place. Inside our earth, when we take crust, below that you have magma, mantle, and in the mantle you usually see the warm ones rising. They move in this direction, they cool down and they come down. So there is circular movement of magma below the crust as well. Because of this, can you see both are moving away from each other? That is, they are moving in this direction. There will be certain cracks coming up. Different features are actually observed in the Earth's surface because of the movement of the magma below this. Whenever the magma moves, we know that the crust is actually divided into multiple plates. Now, these plates, wherever they are broken, they start moving. For example, if I take this as the point, then due to magma movement, it will start moving like this. Or if the magma is moving towards each other, then it will start moving like this. Because of this, multiple features are formed on the Earth's surface. So this is very, very important for us to understand initially. Right? So let's quickly look into the basic NCERT books where they explain about these processes. So in the activity, they are talking about the paper ball experiment which I just explained. Here they want to tell you that with boiling, hot water rises. This we have seen. Now, when we are talking about lithosphere, I told you the lithosphere is broken into number of plates known as lithospheric plates. And you will be surprised to know that these plates move around very slowly. It's not heavy movement, very few millimeters movement over a year. This is because of the magma movement inside the earth. I told you this. Then the movement of these plates causes changes on the surface of the earth. On the basis of the movement, this can be divided into endogenic forces and exogenic forces. What is the meaning of it? If the forces are acting inside the earth crust, that is because of the movement of the magma, we call it endogenic. Endo means inside. But if any action or forces are acting on the surface without involvement of the magma, we call it exogenic forces. For example, river action may actually lead to erosion. For example, a river is actually flowing. Whenever it goes and hits the mountains continuously for over years, you see river breaks the mountains into small particles. Not the entire mountain, only a small block of it. Now, after this what happens? The small particles are being carried away by the river and they deposit it at different places. Because of this river movement, we see erosional activity of the rock and we also see depositional activity of the sediments. I also explained this when I was talking to you about the rock cycle, isn't it? So here we are talking about different structures that are being formed, that is erosional features and depositional features. It is not only rivers, we look at air or wind, we look at sea caves or ocean waves. All these play a very important role in changing the structure of the Earth's crust or the features that are present. Earlier, it is believed that even Aravalli mountains were very huge. But because of the wind action, and it is believed there was a river before there, and because of those actions, we usually observe that the height of these mountains has reduced. So this is very important for us to ensure that we have clarity about this. That is, if there is any action inside the earth crust, we call it endogenic forces. If there are any action above the earth surface, we call it exogenic forces. Now, the endogenic forces, as the table clearly shows, can be differentiated into sudden forces and diastrophic forces. Diastrophic means slow forces. For example, just consider two plates. You have Indo-Australian plate and you have Eurasian plate. These two come closer. I have told you the weight of the continental plate is less when compared to the weight of the oceanic plate. So because of this, what happens? We usually see the continent and ocean together, which is present in Indo-Australian plate, because you have Indian Ocean also, you have India and Australia, but in Eurasia you have only continent. So continental will be less weighter, whereas when we talk about Indo-Australian, it will be heavy. So now what happens? Because of this, they both come closer and the Indo-Australian plate go below. And because of this, we usually see Himalayan mountains being formed. These are slow mountains which take generations to happen. Here we are giving an example of building mountains. Whereas there are certain things which take hundreds of years inside the earth, but on the surface of the earth it will be seen in fraction of seconds. Sometimes it may be for 1 or 2 hours, but most importantly, you will see in fraction of seconds. These are called as sudden forces. The meaning of this is earthquakes. Let me take a simple example of Nepal earthquake. When we were actually talking about the Eurasian plate, which is meeting the Indo-Australian plate, right? In between you have Himalayan mountain ranges. It is believed that Indo-Australian plate moved towards Eurasian plate every year, some centimeters. They keep moving. Because of this, the Himalayan mountains are still rising a bit. And we call it young fold mountains. Now here what is important? It is believed that when Indo-Australian plate is pressing against the Eurasian plate for generations, 75 to 100 years, when we press a lot, what happens? The rocks which are there in between, they break into small pieces because you're pressing it for longer period of time. And because of that, what will happen? Those rock particles will become sand and their space reduces, it will fall down. And there will be a small gap between these two, and this leads to some movement. I'm just telling you, if you actually press anything for longer time, in between there will be a small crack, those particles will break and they fall down. and there will be slight movement of these two. Or we can just tell whenever it breaks, there will be some gap and it will fill. At that point of time, we usually have earthquakes. Nepal earthquake actually happened because the Indo-Australian plate has pressurized Eurasian plate for longer period of time. That big rocks, they broke because of this pressure, and that led to earthquakes happening in Nepal. This is what we say earthquake waves. Whenever we talk about earthquake waves, we usually say that the earthquake waves come to the surface from the point where earthquake has happened. So here, if I am taking a small portion of the crust, and if I say earthquake happened here, this portion will be called as focus. This portion will be called as epicenter. Right? Now from this focus, waves will move in all the directions. The first wave which comes out is called as primary waves or P waves. They usually travel in the form of sound. That is, you will see waves closer and then you will see waves farther. You will see waves closer, you will see waves farther. So can you see compression, rarefaction, compression, rarefaction. This is how the sound also moves. Here, if you have a particle, this particle will be compressed. Here, the particle will be expanded. Compressed, expanded. Here we usually observe that the movement of the particle is parallel to the movement of the wave. Correct? So we are seeing two things. P waves are similar to sound waves and they are compression, rarefaction, compression, rarefaction. And because of this, we see certain particles here which are compressed, they are expanded, compressed, expanded. And other property is they can pass through both solids and liquids. I'll explain these concepts in detail in further classes, but I want you to know about these. Next important thing is secondary waves or S waves. They actually come and reach the surface after P waves. Now how does this travel? This travel as light waves, transverse waves we call, like this. If you have a particle here, the particle will move up, it will move down, move up, move down. Can you see the movement of the particle is up, down? We call it perpendicular to movement of waves. So here I am talking about S waves moves like light or transverse waves, and you have particles moving perpendicularly. P waves parallelly, correct? Now P waves and S waves, they reach the point I talked about, epicenter, right? They reach the epicenter. Once they reach the epicenter, P waves and S waves combine. So what happens? If you have a particle, P waves was pushing it above and below, because if this is the surface, P waves was traveling like this. So when P waves travel like this, movement will be also like this. S waves was moving like this. If S waves move like this, how will the particle move? Like this, because it is coming like this. I told you perpendicular, it will be like this. P waves were pushing the particles like this. S waves was pushing the particles like this. Because of this, the building will actually undergo first a push by P wave, push by S wave, down by P wave, and pushing back by S wave. It happens in fraction of seconds. If I start here, it moves like this. So if I am moving like this, the building falls down. This is the reason you see during earthquakes there will be shake. Why? Because it happens like this. P waves and S waves are present inside Earth. So we call it body waves. When they combine and come out, we call it surface waves. And you should also be aware what creates damage Because of earthquake, it is surface waves, not body waves. Is it fine? So, areas whichever is closer to epicenter will experience maximum earthquake impact, whereas areas farther away from the earthquake experiences less earthquake impact. The reason for this is epicenter is the place where the force is maximum and the wave action is maximum, impact is also maximum. Right, guys? So these points are important for us to understand earthquakes. I'll explain you volcanoes and other factors explained in the chapter now. We gave example of earthquake waves, we gave example of volcano and landslides. What is the meaning of landslides? Whenever there is shake inside the earth, the mountains and rocks whichever is there, they fall down. That is also seen to be an example of endogenic forces. Now when I am talking about the exogenic forces, we are actually talking about the erosional and depositional features I told you. Rivers, wind, sea waves and glaciers, limestone are some of the example of these erosional features and depositional features. Then I talked about the lithospheric plates. The Earth's crust consists of several large and small, rigid, irregularly shaped plates which carry continents and ocean flow. This is called as lithospheric plates. Endogenic forces sometimes produce sudden movements and other times slow movements. Sudden movements, examples of earthquakes and volcanoes. I have told you. Now, what exactly is a volcano? A volcano is a vent or opening in the Earth's crust which molten material suddenly erupts. I told you these are sudden outside, but inside it would have taken some generations. Now here, when I consider this crust and mantle, can you see this particular portion, red color, coming out? This is magma coming out in the space available. Here there are some holes, through this it is coming. This is called as vent, and at the border of the opening it comes out. Either the gases or ashes comes out or magma flows in the form of lava. Different names are given to different volcanoes on the basis of its emission. But here, what is more important for us is these terms. Lava. Once magma comes out of the Earth's surface, we call it lava. Now, the gap through which the magma rises is called as vent. The chamber from where the magma rises is magma chamber, and it is present in crust and mantle, we call lithosphere. And then whenever there is a blast, volcano erupts. After that you usually see a lake type structure. That is what we call crater. Can you see here? Crater. I'll be explaining these with pictures over a period of time, but just try to understand these names once. Now, I told you about earthquakes, I told you about focus, I told you about epicenter. This portion is called as focus, where earthquake has actually happened. Immediately above that is epicenter. It happens usually between plate boundaries. We call it a plate boundary. Seismic waves radiate in all the directions. And here they have given you P waves, S waves and L waves. Is it fine? So these factual information is important for us. They have given example of earthquake, a case study which actually happened in Bhuj, Gujarat. And here, do you know is important, where they give you information about the machine that is actually used to measure this, that is seismograph. The magnitude of earthquake is measured on the Richter scale. An earthquake of 2.0 or less can be felt only a little. An earthquake over 5 can cause damage from things falling. 6 and higher magnitude is strong, and 7 is classified as a major earthquake. Nepal earthquake was actually in between 6 to 8. So that had huge impact in Nepal as well. What all measures should we take from disaster management point of view? Safe spot. Under a kitchen counter, table or desk you should hide. Stay away from fireplaces because there is a possibility that there can be a blast. Windows and all can be shattered and those things may hurt you. And be prepared, spread awareness, and you should be knowing what you should do whenever earthquake usually happens. Next, let us take the erosional features and depositional features on the earth's surface. We call it exogenetic forces. The first thing it talks is about the work of a river. Here when it talks about the work of a river, it talks about waterfalls. Waterfalls is formed because of the work of the river. Now you have the highest waterfalls is Angel Falls of Venezuela in South America. Please try to identify it with the help of Atlas, Orinoco River Basin. The other waterfalls are Niagara Falls located in between Canada and United States, again important. And you have Victoria Falls on the borders of Zambia and Zimbabwe in Africa. So these waterfalls you have to locate and it's important from geography point of view. Now, how exactly a waterfall is formed? Let me take two surfaces. You have in the crust, there are certain rocks which are hard and there are certain rocks which are soft. Now, when I have hard rock and soft rock present, usually what happens? We know that hard rock does not erode soon, whereas soft rock erode quickly. Now, when I take this case, I have hard rock and I have soft rock. When river flows, river erodes the soft rock. Over a period of time, this entire portion gets eroded. Now, it looks like this after erosion. Or you may have some particles like this because this is still present and then water erodes in this portion also. But I am just giving you an example. You have a hard rock and a soft rock. When it falls down, you can see waterfalls. So, erosion by river actually leads to waterfalls is what we need to understand. So, here you can actually see hard rock and soft rock and water falling from above. This is an example of erosional feature. Let us see an example of depositional feature. That is, river, when it is moving in this slope, steep slope, river moves quickly, correct? But when it is moving like this, on this river moves slowly, correct? River moves slowly. Here, whenever the level is weaker, you only see when you pour water on a table, initially it will be slow. Why? The table is flat. But once it reaches the corner, it will be fast. Again, once it falls on the ground, it moves slowly, right? This depends upon the slope. When slope is steep, movement is fast, gentle, movement is slow. In steep, erosional features are usually seen. In gentle, depositional features are usually seen. Now, initially when the river is steep, river has more energy to flow. At that time, it carries all the sediments. But whenever the river is moving on a flat surface, river doesn't move straight. It will be moving in this fashion. Slowly it moves like a snake. When it moves in this fashion, it needs energy for movement. So what happens? It cannot transfer the particles. So heavy particles settle first, lighter later, deposition takes place. Here we see whenever the river moves on a steep surface, it carries the material along with it. But when it is moving on a gentle surface, it is moving slowly. And because of the slow movement, deposition takes place. So the slow movement, wavy movement of the river on a gentle slope is called as meanders. And whenever the meander moves in this fashion, sometimes some portions are left. Can you see Oxbow Lake here in the picture? Oxbow Lake. What is the meaning of this? Oxbow Lake is one where river was moving like this. Okay. Now it started moving like this and this portion was left. How? I'll explain in detail because it requires good pictures to help you analyze. But over a period of time, because of some sedimentation in this region, there will be cut off and this portion connects. So the river leaves some lakes in between. These are oxbow lakes, right? And then deposition of the sediments by the rivers usually leads to floodplains, and on these floodplains only you grow crops and all. Fertile soil is present here. The raised banks are called as levees. When the floodplains, that is deposition on either side, when the river is moving in this direction, deposition keeps happening on the either side. If the height increases, we call it levees. At the end, the river actually enters the ocean. The place where the river enters the ocean is called as the mouth of the river. When the river enters the ocean, ocean has salt water, river has fresh water and sediments. Now when these two mix, the salt water does not allow the sediments to come in, and the sediments get deposited at the mouth of the river. When this deposition takes place, we usually see deltas being formed, right? So river which is coming like this, it gets split into the ocean. When it gets split and it enters into the ocean, sediments get deposited. This is what we call delta. Then we have to look at the work of sea waves, right? You have to look at the work of sea waves. Now, you know that waves, whenever they move, they also erode. How exactly they do? I'll explain you. You only see this portion in the waves, correct? Usually water particles, what it happens, it moves like this and it comes back. Water does not transport or water does not travel. Usually below wave, this movement is seen. Usually we see circular movement. This is wave action that you see. That's why in the pool, when you have any ball or anything, it keeps moving like this. It does not travel easily along with the wave. It moves like this and slowly it comes. Now, you can observe that the wave is moving like this. If I have land, the wave comes and falls here like this, and then it moves on the ground. When it moves on the ground, it quickly moves out. You know that whenever you pull a chair, roughly, any heavy particle above the surface of the rock, when you bring it, you usually see some pieces or some cracks or some lines on the rock. Those are the erosion of that rock or either the table or chair that you have brought in. So if you push the chair, and if chair is strong and the stone is weak, stone breaks into pieces, or you see some scratches. Or if the rock is strong and the chair is weak, we usually see some scratches on the chair. This happens everywhere. So whenever you push, that cracks will be there. That cracks or some scratches will lead to some erosion. So waves will also lead to these erosions. Now, let me take this picture. Whenever waves come and hit these rock structures that is shown in the picture, initially there will be some erosion which leads to sea caves. Later, with further erosion, the entire cave, initially only a small portion is eroded. We call it cave. Over a period of time, there will be a hole. We call it sea arch. After that, this entire portion will be eroded and only some rocks will be standing. This is what we call stack. Within this rock, based on the hardness or softness you see, or based on the movement of the waves, you see different portions. So this is what we call sea caves, sea arches and stacks. Any steep portions are called as cliffs. That is, if you have a rock, one side is curved, another one is steep. So this steep portion is called as cliff, and this is formed because of the erosional activity. After this, we need to see work of ice. As I have already told you, whenever we bring any particle, that is chair or anything, there will be some portions melted. Similarly, glaciers, they move because of the gravitational force, or sometimes during summers, melting of water will lead to movement of these. Whenever these glaciers move down, usually they move on the rock surfaces below it. Because of that, there will be some scratches found below. That is what we usually called as the erosions of the glaciers. Now these particles will be deposited. They may be of different sizes, and these deposits are called with different names, and one such is glacial moraines, which I will be explaining in further classes. Then at last, we have wind action, where due to wind, let me take, there was a rock like this. Wind from all the directions is moving. Wind does not have the property to erode. But usually what happens, wind whenever it is blowing, it carries the sand particles. Wind along with the sand particles, when it goes and hits this rock, usually we observe some erosion of the rock. Over a period of time, this erosion increases and it looks like mushroom. I hope you are getting the point. Or this wind may go and deposit sand somewhere in the form of sand dunes. In deserts, you can see some dunes in this shape. So here in the picture, you can actually observe these wavy shapes, which we call as sand dunes. I explained mushroom rocks, right? And huge areas of sand deposits is usually called as loess. It is actually seen in China. I will be explaining you all these again with the help of pictures, because we will be taking other classes also. As it is introduction class, they have given only a little information. I too don't want to dig in detail, because this alone will take not less than 3 hours for us to understand, but without pictures it doesn't make any sense. So guys, for last 1.5 hours, we have seen some of the major chapters with some basic concepts. I have tried to explain those basic concepts now itself, because it will be easy for you to understand further classes where application is important. Now you can take a break. Please read all these once before you start again, right? This will be part 1, where we'll be focusing only on the first 3 chapters. Later, I'll take other chapters where, based on its importance, I'll be spending time. Fine guys, thank you, thanks for watching.